Okay, today we are continuing on from what we did on Friday. We're still using the sum and difference identities, and we're going to do two things with them. We're going to use sum and difference identities to write a trig expression as an algebraic expression, and then we're going to use sum and difference identities to verify a trig identity. So those are the two things we're looking at today. I believe it takes 5 examples to do this. Alright, so here we go. We have cosine of inverse sine of x plus inverse cosine of 2x. Cosine of inverse sine of x plus inverse cosine of 2x. And this is the first one where we want to take it from a trig expression and rewrite it as an algebraic expression. So does anybody notice what form we are sitting in right now?
Cosine A plus B.
We're looking at cosine of a plus b. So what is a and what is b?
Sine, negative, inverse of sine.
So this right here is a, and that is b. So I need to plug this into my cosine a plus b formula. So we're going to get pretty long on this. So I have cosine of a, which is inverse sine of x. I have cosine of b, which is inverse cosine of 2x. Then I have minus sine of a and sine of b. So make sure you understand how that's laid out. Remember, this is a, this is b, this is a, that is b. So I just plugged it into the cosine a plus b formula. So now we want to go through and work these out, and there are 2 of them that are very easy to do right now. Which 2 are very easy to do right now?
Cosine, inverse cosine, sine.
Very good. So as Natasha said, this right here and that right there are very easy to work out. Lauren, why are those easy to work out?
They're the same. Cosine,
Kaylee, why are those easy to work out?
the same trig, I mean. I don't know.
Christian?
They cancel out.
They cancel each other out. A function and its inverse will cancel each other out, so that means this one produces 2x and this one produces x. Oh, is it?
I said it's the same trig.
So now I need to evaluate these 2. And let's see if you guys remember how to evaluate something that is in that form. Anybody remember what we need to do to evaluate those 2 things? We would try to find the inside first, but the inside is dealing with an x, so I'm not going to be able to find it. And so that means I've got to do something else with it. You guys remember what we need to do with it? No? What were you mumbling, Lauren?
I don't remember.
Gage, you remember how to work those out? Cosine of inverse sine of x or sine inverse cosine of 2x?
You those for 1?
Nope.
You didn't say size.
No.
No, I'm not sure. I don't have.
I think it's a white.
This was 2 units ago.
Oh, that's like 12 years ago. Math.
I've slept since then. Oh, wait, hold up. All I remember is that you saw you filled the middle and then you saw no, but you can't solve since
You can never do things in that
I think we did this the last thing we did before Christmas break.
Oh, way too long ago.
Oh no.
Do you,
He usually one hit. You just get
One hit.
Make a triangle.
It was
There
before
we go.
Christmas break.
Did
There
you
we
say
go.
make a triangle?
Yes.
I literally said that. I said there's a triangle in here, maybe that.
I didn't hear you.
You were lying.
No.
So I need to draw a triangle.
Wow.
I really tried.
So I draw a triangle with the inside information. So what do I know about the triangle with the inside information? What do I do? So what can I label?
No. No.
No.
No.
X is what?
Opposite.
X is the opposite, and
The hypotenuse.
is
No.
1. Then what do I do to find the third side?
1 squared minus x.
The Pythagorean theorem, which is the square root of 1 minus x squared. Then once I have my triangle drawn, what do we want to do?
You want to find out what
Plugging it.
Cosine, which is
We want to find cosine. So what's cosine going to be?
adjacent over hypotenuse.
Adjacent over hypotenuse, so that would be the square root of 1 minus x squared. Whoops. Just need to do that. Alright, so then we go over here on this one. What do we know about this triangle?
Cosine, which is adjacent over hypotenuse.
Adjacent is 2x.
Adjacent is 2x, and
Hypotenuse is
hypotenuse is 1. So what is the opposite side going to be?
1 minus 2x.
So 1 minus 4x squared.
Yeah.
And what would sine be?
1 minus
Square root of 1 minus 4x squared. So there's that. And again, when we're doing sum of difference identities, what did I say should always happen? Denominators should be the same. Very good, Sky. And in this case, denominators are both 1, so we're good to go.
You're being cruel today.
You said it too, but I heard her. She was standing right there.
So you don't get any recognition.
So to clean this up a little bit, to make it look a little bit prettier, that's what we're looking for. Because Christian, what was the objective to this problem? What was our goal?
Changing it to a trig
It started out as a trig expression, and we turned it into
algebraic.
an algebraic expression. So we started with a trig expression. We used the sum of difference identities to rewrite it as an algebraic expression.
We don't have to solve.
That's it right there. That's what I want.
Sorry, it would have been bad.
All right, let's look at another one. I have cosine of arctangent of radical 3 minus arc cosine of x. Same thing. We want to take it from a trig expression, use the sum of difference identities, rewrite it as an algebraic expression. So cosine of arctangent of radical 3 minus arc cosine of x.
So we have
Now we have to make a
cosine
cosine
A.
Cosine A minus B. So we have cosine arctangent of radical 3. We have cosine arc cosine of x plus sine arctangent of radical 3 and sine arc cosine of x.
You can cancel out one of those.
We can cancel out one of them. That is correct. Which one is that?
Arc, cosine and arc cosine.
So I can take this one right here, and I know that reduces to x. Okay, now what's different about this problem versus the one we did, the first one we did?
Only one can.
Yeah, and it doesn't have, like that one has sine and then sine.
We have
Yeah, we only have
three
one that can
different
size.
trigonomic functions.
Alright, there's a different trig function. This one has arctangent in it. What else is different?
It's not all x's.
It's not all x's. We have a number in here. Do we know what arctangent of radical 3 is?
Yes.
Yeah.
Tangent radical.
Yes, we should know what arctangent of radical 3 is.
Pi over 3.
Pi over 3. So this is the same thing as pi over 3. So what is cosine of pi over 3?
That would be 1.
Yeah.
No, I
One.
mean, sorry.
1/2 is correct. If that's 1/2, if that's 1/2, what does the other one have to be?
Square root of 3.
Square root of 3 over 2. Very good, Bobby. And then what do I need to do on sine or cosine of x?
Triangle.
Triangle. Very good, Kaylee.
Sounds right.
She knew that one.
So what do I know about that triangle, Reagan?
That's the, so the adjacent is x and hypotenuse is
1. So then we use Pythagorean theorem. Means that that's the square root of 1 minus x squared. So Gage, now I'm interested in sine. What is sine of that triangle? What is sine of that triangle? What's the definition of sine, Gage?
The opposite over hypotenuse.
So what would opposite over hypotenuse be of that triangle?
1 minus the square root of 1 minus x squared over 1.
Very good. Okay, and as should happen, Hunter, what do we notice? It's got fractions and the denominators are the same. So my denominators are both 2. So I have x plus, since these are both radicals, I can distribute the 3 in there and make it 3 minus 3x squared. And we have reached our goal. Both.
Okay, we'll try to look at it.
And Colleen, what was our goal?
To make it into
Take it from a trig expression and make it an algebraic expression. Very good. We have done that.
Okay, good.
Alright, let's do it with tangent. So this one is tangent of inverse cosine of x plus inverse tangent of x. Tangent of inverse cosine of x plus inverse tangent of x.
Tangent A plus B.
This is tangent a plus b. So we have tangent inverse cosine of x plus tangent inverse tangent of x over 1 minus tangent inverse cosine of x tangent inverse tangent of x.
Okay, you can. So you can cancel out the tangent.
I can do that. I can cancel out the tangent inverse tangent of x. So that makes it pretty nice.
It's pretty sweet.
So this becomes x right here, and I have an x on the bottom. With that, I've taken care of both of those. And what do I need to do to take care of these other two? I need to draw a triangle. Okay, Hunter, what do we know about those triangles?
If the hypotenuse is 1, x, 2, something.
Cosine, you know cosine.
No cosine.
So what does cosine tell me?
That is the adjacent is x.
The adjacent is x, and hypotenuse is 1. So that means the opposite side has to be the square root of 1 minus x squared. So Christian, I now want tangent of that triangle. What is tangent of that triangle?
Opposite over adjacent.
So square root of 1 minus x squared over x, and square root of 1 minus x squared over x. We're not done yet. Bobby, multiply by x. Now let's do something before we do that. Let's go ahead and cancel these two. And then let's multiply top and bottom by x.
Why do you multiply it?
Because I've got a
Okay.
fraction of the fraction, so I need to multiply by x.
Yeah.
So Kaylee, what does my numerator end up being?
Square root of 1 minus x squared plus 1. X.
x squared. Lauren was my denominator ended up being.
Hold on, okay. This is my problem. I have x minus x squared is 1 minus x.
Very nice. And again, we reached our goal. Gage, what is our goal on these problems?
Solve the thingy.
Hunter, what is our goal on these problems? Take it from a trig expression and turn it into an algebraic expression using some different identities. All right, last one.
Yes, I mean,
There was 5. Yeah, you said there was 5.
I said there's 4 or 5. All right, so we want to verify the identity, and we want to use some different identities to verify this identity. So we want to prove that cosine of pi minus theta is equal to negative cosine of theta. Cosine of pi minus theta is equal to negative cosine pi, or negative cosine theta. So I'm going to do the left side. And Sakai, what do we notice about the left side?
it's minus, or a minus b.
It's cosine of a minus b. Very good.
Oh, yay.
So it is cosine of pi, cosine of theta, plus sine of pi, sine of theta. Very good. So we notice that's cosine a minus b. We plug it in. All right. Now what can I do after I plugged it in?
You find out what cosine.
Very good. I can evaluate cosine of pi and evaluate sine of pi. To be able to evaluate those two, what do I need to know? I need the ordered pair of the graph. And what's the ordered pair of pi? Negative 1, 0. So which one of those is cosine? Negative 1. Which means that sine has to be 0. So we notice 0 times sine, that goes away, and I have negative cosine of theta equals negative cosine of theta, and I have proven that identity using the sum of different identities.
See, that's a lot easier whenever we work that all together.
Yeah, and then you do some homework, you like different stuff, and you just looking dumb.
Atmosphere, we try to do it.
Exactly.
Well, I do.
All right, so
Like, that one was easy.
what two types of problems did we deal with today?
Turning trig into algebraic.
Turning a trig expression into an algebraic expression and
And verifying.
verifying a trig identity using the sum of difference identities.
Yes.
Stuff.
All right.